Hello and welcome back. Well, we're getting into the home stretch now. We have all the hardware set up and the only thing left to do is get the software, the Arduino sketches running on these two boards here. Since the last video I've added a couple of little things. I just zip tied the battery alarm thing on here because this is where my battery balance ports are going to come out, so I'm just going to stick that on there. These are only $3, so I'm just going to permanently stick this on here and just buy another one to put on my other quadcopter. And the other thing I did was add some of these foam blocks to be landing gear. These are just the kind of hard foam blocks that you find in those kids jigsaw puzzle kind of floor mat sort of things. Don't worry, I didn't steal any kids jigsaw puzzles. So yeah, what we need to do now is put the receiver sketch onto the Pro Mini on this side. I've already done that, so I'm not going to bother doing that in the video here, but we'll have a look at the sketch and what it does. And then we also need to put the MultiWii software onto the flight controller board, and I will go through that because that's a little bit more involved.
Now, the purpose of the receiver sketch, if you recall, was to take the radio information coming over the radio from the radio module and convert that into PPM information and put that out onto signal pin 2 to give to the flight controller board. So I'll just go over this sketch pretty quickly. I don't have any nice comments in here yet. I will put some better comments in before I upload it and while I'm editing the videos and such. So we connect up our radio module like that. We've already done that. So we need to set up a few configuration things for the PPM. I'm going to be using Chanel number 6. It should be two N's there, shouldn't it? I actually got some of this code from some forums on the web somewhere, and I forget where I got them from, but I should probably credit the guy who wrote this originally because it was very handy and I didn't actually know how to do it myself, so I've just copied some of these. That's why the spelling is wrong. Not my fault. Anyway, so we're going to have 6 channels. We're actually only using 4 at the moment, but I'll just put 6 on there to show how we could use some more. Default servo value, actually we're not going to be using that, don't worry about that. So signal pin is 2. That's the pin that we're going to be using for output given to the flight controller. And then there's a couple of values here which I wouldn't touch. They're just the number of microseconds between pulses, and I think this is the overall length of this one frame. Yeah, that's right. So 27 milliseconds per frame length. And then we have an array of integers that are going to be the actual values that go out over the PPM line. The pipe address for the RF24 module is the same as the one that we had on the transmitter. This is just saying which pins we want to use with the radio module. Okay, so then we have the data structure. Now this little bit here should be exactly the same as we had in the transmitter. Just the 4 bytes, and then we have an instance of that which I'm going to call data, which is a bit of a vague name. I should give it a better name. So to reset the data, that is to set it to the initial value, and also we're going to use this if we lose radio contact. We're going to use this function here to reset the values to something that's potentially safe. I mean, it's just going to cut the throttle to 0, so if we lose radio contact while we're flying, it's just going to drop out of the sky, but that's potentially better than flying off. And then after we've done that, we will call this function set ppm values from data, and what that does is it just copies in to the actual ppm values that we're going to give to the flight controller. We're just going to map the values that we got from the radio, which were from 0 to 255, and we're going to map that into a range from 1000 to 2000, and these are the values that the MultiWii software is expecting for the far left and far right of the stick positions. And then our 2 auxiliary channels here, channels 4 and 5, they're just going to be set to 1000. So basically 1000 is the lower end of the scale, which means the switches are off. So if we had two switches on our controller, this would be the off position, and 2000 would be the on position. And you can actually have mid positions at 1500 if you want to as well. Okay, set up ppm. I'm not going to bother explaining that one. That's a bit tricky. I didn't write that part either. So at the beginning we do the setup of the ppm, and then we do the same radio stuff that we did on the transmitter, and this bit is also almost the same, except we open a reading pipe instead of opening a writing pipe, and then we do start listening. And before we kick everything off, we do reset data to set everything to the safe values. Right, so in the loop, this is the main loop, we do this over and over. We do receive data, which all that does is it checks if the radio has any data available to read, and as long as there's data available, it just reads as much as it can, and then it sets this last received time value to the current time when it successfully got something. So we do that, and then we check if the current time now is more than 1 second after the last time we received some information from the radio. So if 1 second has passed since the last message we got from the radio, we're going to interpret that as that the radio contact has been lost. So what we do then is reset data to the safe values, so potentially causing a crash, but also potentially preventing it from flying away. And then in here, also very important, we need to set the values in that ppm array from the data structure. So that's what happens in the loop. And then the part down here, I also did not write this. I modified it a little bit, but this works using an interrupt. So we're using timer 1, which has this value here, and we set that to a number, and then the timer will tick up and up and up, and when it hits that number that we set, it's going to jump into this interrupt. Interrupt something routine. I can't remember what that stands for. I'm a great teacher, aren't I? Anyway, so it's going to jump into this function when it hits when that timer counts to the right value, and basically we're just going to switch digital to pin 2 off and on very quickly. That's why we need to use this interrupt, and the timing is very, very important because it's working on millisecond ranges, and so everything everything that happens in here needs to happen very quickly. This line here is the one that I changed. I was having some problems with this with my previous quadcopter build. This didn't turn out to be a problem, but I left it as it is anyway. This is basically just doing a digital write, so it's actually turning pin 2 off and turning pin 2 on there. So come to think of it, okay, yeah, if you change this sketch to use something other than pin 2, you might just want to what you can do is change the position of this 1 here, so it's starting from the right. We have, that would be pin 0, pin 1, pin 2, so that's why there's a 1 in this position. So if you wanted to use pin 3, you would change this to that value like that. But what might be a little bit easier is just to comment this line out completely and just do digital write. So if you changed it to pin 3, you would put pin 3, and that would be then 0, I think. Is that how that works? So you would want to turn pin 3 to 0 there, and then in this other place here you would want to also do digital write there and turn it to 1. So if you want to change the pin from 2 to something else, that's what you would have to do. So I might make this a little bit clearer and set it up a bit easier for when I actually upload this to my site for you to download. Anyway, so I've already put this onto the Arduino, and the next thing we need to look at is the MultiWii software itself. To find the MultiWii software, go to Google and type in MultiWii, and it's probably the second one here, MultiWii Google Code. And if you go there and look under the downloads link, the one that's the most recent one, at least at the moment, in November 2014, is release 2.3. I'm not going to use the development build at the moment. So get that zip file and unzip that somewhere, and you should find it contains 2 folders like this. Now the first folder here is the Arduino sketch that we're going to upload to the flight controller. There's quite a bit to it, but the one that we need to open is this one here, multiwii.ino. So that's the main Arduino sketch file. And in the other folder here, multiwii.conf, there is a set of pre-built applications that we're going to use after we've uploaded the MultiWii software onto the flight controller. We're going to use these applications, or one of them, whichever one your operating system is, to connect to it and change the settings. So I already have this open here in my Arduino IDE. So when you open this, you'll see this one. As you can see, it's completely commented out, so this one doesn't actually do anything. And if you look at the other tabs, these are all divided into sections of code that actually do things. And there's quite a lot to it, but there's actually only a very, very small number of changes, only 3 lines that we need to change in here for this particular flight controller board. So if you go in the far right corner, this is going to be off the screen actually, but let's see if I can get it on. There we go. It's still off the screen, unfortunately. But right down the bottom you'll see a tab called config.h. So, oops, lost it, sorry. Config.h. So this is where all the configuration is taking place, and there's not really much that we need to change here. You can read through all the comments here and do some other changes, and there's a lot of information right here on YouTube where you can find out how to do various things. But for the purposes of what we're doing now, there's only 3 lines we need to change. So we're going to uncomment quad X from the very first section, so that defines the type of multicopter we're using. And then a little bit further down we should see combined IMU boards, which is what we're using because we have the accelerometer, gyroscope and all that stuff on one board. Now you'll probably notice on here that there's a lot of these combinations that have the triplet of MPU 6050, which is the accelerometer that we have on this board, HMC 5883L, which is the compass that we have, and this one here, BMP 085, that's the that's the barometer. And a lot of them have that setting like that. So it's there, it's there, not quite, but anyway, you get the point. It's very, very common. So I just played around with trying some of these, and I found that this one here, Hobby King board with MPU 6050 and blah blah blah, so this one here works great. So uncomment that one, Hobby King board, and then the only other thing we need to change is where the ppm is defined to be enabled. So I'm just going to search for ppm sum receiver with a spelling mistake again. Let me just fix that. There we go. So we need to uncomment one of these lines here where we are defining that we want to use ppm signal, and also what order the sticks or the axes are going to be defined in. And you may, if you're using the sketches exactly the same as I have, I think I put, let's see, throttle your pitch roll was the order that I put mine in, so we'll need to change the ordering of these. So I'm just going to copy another line and uncomment that, and this is going to be for G passes, and we're going to have throttle your pitch roll. Yeah, that's right. So that's the ordering that we have in our data structure for our other thing, this one here. So this has to match with what we just set there in the multi-wii code, throttle your pitch roll. Okay, and that's it. So we have to load that onto the flight controller board, so I'll just do that quickly. Let's see. Okay, now back in the downloaded folder for the multi-wii stuff. This time, now that we've loaded the actual Arduino sketch onto the flight controller board, we can talk to it. So keep the USB connector thing, the FTDI adapter, keep that connected to your flight controller board after you've uploaded the sketch from the Arduino IDE. Now we go into the multi-wii conf folder, and I'm using Linux here, so I'm going to go into the Linux folder, and there'll be multi-wii conf. This is a program that we can run if we set it to be runnable. So hold on a second. We need to set that. You can use chmod if you're using the command line. Alright, let's try that again. So this is the multi-wii configuration control panel sort of thing, and this is talking to the flight controller board over the USB connection, except right at the moment it's not, because I forgot another thing, and that is that the way I have things set up here, I need to run this as root in order for it to be able to talk to the Arduino stuff. I actually have to run the Arduino IDE as root as well. I haven't quite figured out why, but doesn't bother me too much. So hold on a second. Just cd into this folder and run that as root. This time it should work. Okay. Now, if it's working correctly, you should see on the left hand side here, you should see your USB device, and when you click on that, these buttons should go green if it connects properly. And to check if all the electronics on there, the gyroscopes and accelerometers and everything, are working correctly, you can click the start button here, and that should show some information in the bottom white rectangle, and when you move the quadcopter around you should see all those values giving you some feedback. So make sure that the quadcopter is nice and flat. So this is, we're going to calibrate the accelerometer, so keep that as the position that you want it to consider as flat and level, and then click on Calib ACC and just give that a few seconds. Now if you see things moving around at this point, even though you're not moving the quadcopter, it could be that the gyroscope didn't get initialized properly. So if you look at the gyroscope values here on the bottom left, they're all 0, and if you're sort of bumping the quadcopter around a little bit like this when you first start up, the gyros will be initialized to something that is not 0. So when you first connect up your battery and stuff, you want to make sure that you give it a few seconds to just sit perfectly still, so that it knows what it means to sit still. Sounds like a little kid. Sit still. Anyway, so as long as these are 0, you shouldn't have any trouble with the pitch and roll wandering. So to check that all the orientations are correct, if I pitch the quadcopter forward like this, we should see the pitch in the upper right area here is pitching with the quadcopter when I move it, and if I roll, it's also rolling the correct way. So of course I have this is the front of the aircraft here, so that's rolling left, right and left, pitching forwards and back. That's great. And it's also yawing as well, and I think it's using the compass for this. Is that right? Yeah, that's north there roughly, so it does seem to be using the compass, so that's great. Everything is working just nicely. Next thing to check is the inputs. So at the moment you can see at the top we have throttle, roll, pitch and yaw. Roll, pitch and yaw are all right in the middle, so they're a little bit above 1500. They should be right on 1500, so I'm not quite sure why that is. But these values are coming from the ppm output that we have in our Pro Mini right there next to the flight controller. So this at the moment is our safety values, the ones that we have in the reset, where is it? Reset something or other. Here, this one here. So throttle's 0, and then the other ones are at middle. Middle being 128 here, because this is a 0 to 255 value. Anyway, so that's what we're seeing there. Now, if everything is working well, with a bit of luck, we should be able to now turn our radio on and see those values moving around when we move the sticks. So that is roll going to the right and left, pitch down and up, and then we have throttle and yaw on the stick here. So that looks like everything is working just fine. Now I had to reverse the directions of the sticks on the transmitter, and I did that by changing the sketch, and all you need to do there for that is to, where is it? If we look in here for a second. So if you recall, originally this was mapping from the 0 to 1023 range, and originally I had it going 0255 here. So all you need to do to reverse the stick directions is change these last two parameters. So this is on the transmitter. I did this. I just found that to be the easiest place to change things. So if you find that any of your axes on your control sticks there are backwards, then that's how you can fix them. Now you'll notice that there's a pretty terrible dead zone. I'm just moving the throttle up and down now, and even though I'm moving it, it gets stuck in the middle for a long time, and then it sort of jumps quite quickly down to nothing. So I'm beginning to think that this is really going to be a really bad issue. Possibly may even be so bad that these sticks are just not going to work. These potentiometers on here are just not going to be doing it for us, I think. That's really unfortunate, but I'll give it a try first. Alright, and one other thing that we can check at this point before we start to fly it is that the arming and disarming setting is working. So the default to arm the quadcopter, the default setting is throttle down and yaw to the right, and there's a little green LED. It flashes when you tip it to the side, but let's just put it down then. So the little green LED there will come on when the quadcopter is armed. So if I move the throttle to the right and down, you should see that come on. Okay, so now if I had a battery connected, I'd be ready to fly. I don't have one. I'll just get one. And to disarm it, we move the throttle down and to the left, and then you'll see the LED go off. So that's disarmed. Let me just get a battery.
Okay, so I have a battery connected here now, and this time when we arm the flight controller like that, so a little LED comes on, now we should be able to throttle up and see that the motors will spin. So there we go. Okay, so far so good. Oh, by the way, take the propellers off if you do this. Obviously, you don't really need to have had them on at any point so far, so you probably don't have them on. But just in case, obviously, don't do this with the propellers on. So the motors are spinning and the throttle, they're responding to the throttle. What we can do just to check, although it's pretty obvious that everything's working because we can see in the control panel thing that it's detecting the roll and the pitch properly. But if you like, you can just hold the quadcopter a little bit like this, and when you spin the throttle up a little bit, as you tilt it, you should find that the motors on the lower side spin faster than the ones on the higher side because it's trying to correct itself, right? So it's a little bit hard to tell, especially on camera, but when you're doing it in person, you can sort of get a feel for whether it's doing it correctly. So it'll be something like this. It's not really a good test, but I just find it comforting to do this before I try flying it to see that it's actually conveying the information that it's getting from the accelerometer into the motors. And another check that you might like to do is to see if the pitch and roll movements are taking effect. So you could spin the motors up a little bit and do some pitch and roll movements and just listen for the change in tone to see that that your pitch and roll is actually being listened to. So it's like this. So once again, it's not such a great test, but you should at least be able to see that when I push it forwards, the motors at the back spin up. If they tend to slow down a little bit on their own sometimes because I only have the throttle on a little bit. But yeah, so just check that it's responding to all your inputs there.